Namaskar, I'm Nidhi Kumar and you're watching Science Time, a show that brings to you the best that science can offer, from exciting developments in science and technology to futuristic solutions. Well, five more Indian wetlands get a Ramsar recognition of international importance. COVID-19 raises risk of diabetes, heart disease months after infection, according to a study, and new computational framework to help develop efficient batteries. And let's take a look at story number one. Five more Indian sites have been recognized as wetlands of international importance under the Ramsar Convention. Three of these wetlands are in Tamil Nadu and one each in Mizoram and Madhya Pradesh, making a total of 54 Ramsar sites in the country. The sites include the Karikili Bird Sanctuary, the Pallikaranai Marsh Reserve Forest, and the Pichavaram Mangrove in Tamil Nadu, Pala Wetland in Mizoram, and Sakhya Sagar in Madhya Pradesh. The emphasis that Prime Minister Narendra Modi ji has put on environmental protection and conservation has led to marked improvement in how India treats its wetlands, and how India's total of Ramsar sites has now risen from 49 to 54. And the Ramsar recognition aims to develop and maintain an international network of wetlands that are important for the conservation of global biological diversity and for sustaining human life through the maintenance of their ecosystems, components, processes, and benefits. The recognition is part of the Ramsar Convention, an international treaty for the conservation and wise use of wetlands. It is named after the Iranian city of Ramsar on the Caspian Sea, where the treaty was signed on February 2, 1971. And with that, let's take you to story number two. As cases of coronavirus recede across the world while some countries still struggle to manage the outbreak, a new study raises concerns for those infected by the SARS-CoV-2 virus that causes COVID-19. Patients who contracted the virus have a higher risk of developing diabetes and heart conditions months after being infected. Researchers at King's College London have found that the risk was higher in the first 3 months after getting infected by SARS-CoV-2, and the levels could only return to baseline 23 weeks after for diabetes and 7 weeks for cardiovascular diseases. The study hints at long-time risk for people affected by the virus. The study was published in the journal PLOS Medicine, states that diabetes incidence remained elevated for at least 12 weeks following COVID-19 before declining. Researchers also noted that people without pre-existing cardiovascular disease or diabetes who suffer from COVID-19 do not appear to have long-term increase in the incidence of these conditions. And with that, friends, we'll take you to story number three. The migration barrier is a crucial but poorly studied parameter that dictates battery performance. It determines the rate at which ions move through an electrode inside the battery and ultimately the rate at which it charges or discharges, which is harder to measure because the migration barrier in the lab, researchers typically use different computer simulations or approximations to predict migration value quickly. However, very few of these simulations have been experimentally verified so far. In a new study, researchers at the Indian Institute of Science and their collaborators comprehensively analyzed widely used computational techniques. They verified their predictions of the migration barrier values against actual data observed in lab measurements. And based on their analysis, the team proposes a set of robust guidelines to help researchers choose the most accurate computational framework for testing materials that can be used to develop highly efficient batteries in the future. Lithium-ion batteries, which power mobile phones and laptops, consist of three major components: a solid negative electrode, anode, a solid positive electrode, cathode, and a liquid or solid electrolyte that separates them. And while charging or discharging, lithium ions migrate across the electrolyte, creating a potential difference. The electrodes in lithium-ion batteries are not 100% solid. Think of them like a sponge. They have pores through which a lithium ion has to pass, explains Sai Gautam Gopalakrishnan, Assistant Professor at the Department of Materials Engineering, IISc, and corresponding author of the paper published in NPJ, Computational Materials. An important parameter determining the rate at which the lithium ions penetrate these pores in the migration barrier, the energy threshold, the ions need to overcome to traverse through the electrode. The lower the migration barrier, the faster you can charge or discharge the battery, says Rishma Devi, PhD student at the Department of Materials Engineering and the first author of the study. And with this, we come to an end of this edition of Science Time. We'll be back with more exciting stories from the world of science next week. Until then, keep watching Science Time, keep watching India Science. Many thanks for watching. Namaskar.